Hi all. I don't know how to welcome you for this workshop because each one of you are in different time zones. For some, it is early morning, and for few of you, or for some, it is going to be, for a late night. Welcome to this generative AI workshop being conducted by World Resources webinar. I'm going to read out the profile of the speakers. It's a team from the Cambridge Institute of Technology, Bangalore. This is a wholesome one unique team which has done a project on generative AI, being led by Dr. Varalatchoumy. Dr. Varalatchoumy M is the professor and head, Department of AI and ML, Cambridge Institute of Technology in Bangalore. She's an academician with 18 years of teaching experience and 8 years of experience as a researcher. She completed her bachelor's and master's in computer science and engineering, and she did a medical image processing research under Vishveshwaraya Technological University, Belgaum, Karnataka, and has done a major contribution towards detection of malignant tumors at a very early stage. She has led more than 30 international journal publications and 25 patents to her credit. Research Excellence Award, Excellent Paper Award, Academic Excellence Award, and Distinguished Educator Award are some of the few which we can link to her. She has a vast accolades to her name. Dr. Varalatchoumy has contributed as guest editor for the Springer journal titled Systematic Artificial Intelligence, published 3 textbooks titled Operating Systems, Concepts and Fundamentals, Artificial Intelligence, a Modern Approach, and a Full Stack Development. At the head of Cambrian House of Student Startup, CHOSS, at Cambridge Institute of Technology, she has drafted the strategic plan for the entire program and organizes various entrepreneurship training sessions. She has played a lead role at the Nodal Center head in planning, organizing, and executing the Smart Indian Hackathon 2022 event at the Cambridge Institute of Technology, recognized as one of the 75 nodal centers in India and one among 8 nodal centers in Karnataka. Organized first for its kind of innovation and incubation summit event at CI Tech, which performed as a platform for sharing best practices among incubation center heads, corporate innovation centers, and government bodies. To follow her is Assistant Professor Syed Hayath. Syed is an academician with great interest towards data science, artificial intelligence, data analytics, Python, machine learning. He holds a bachelor's in Tripoli from Acharya Institute of Technology and an MTech from BMS College of Engineering, which is a renowned college in Bangalore, and a postgraduate in computational data science from Case Western University. He has been involved in a lot of departmental coordination activities, and he has his accolade attached to launching of the satellite at Cambridge University and making them more focused on projects and fundings. Adding to these 2 stalwarts are the student project researchers. Dinesh D, he's from the 5th semester in AIML at Cambridge Institute. He is working on GUI using Tkinter and currently working on Gen AI. Manu R is a 7th Sem student, and he's worked on a lot of project with corrupted images, completed the AIML course from SIC and published IEEE papers on surgery mortality and prediction projects. Currently, he is working on AI. Then we have V. Sadhana. Sadhana is a 7th Sem AIML student, again participated in various hackathons, WMN, Hack BLR, and she also has a lot of awards to her stream. She has done a lot of freestyle rounds, worked on digital image processing projects to detect corrupted images, like as Manu, and then she is now working on Gen AI. The last person is Dhanush C P. He is the 5th semester student from AIML, the Cambridge Institute, and he's working on creating GUI for one-to-one text messenger using LAN, currently working on Gen AI. With these few words, I wish to welcome the total team to be led by Professor Varalatchoumy to take it forward. Ma'am, it's to you, ma'am.
Yeah, thank you, sir. Thanks a lot. Good afternoon, one and all. So at the outset, we wish to thank Dr. Krishnan sir and the World Resource Webinar team for providing us this opportunity to share the small knowledge which we have gained on generative AI by working on a few industry-oriented projects. So to begin presenting, yeah, I'll be presenting the, you can move to the next slide, Manu, sorry. I'll be presenting the introduction to generative AI, and my teammates will be sharing on the various models and other topics related to Gen AI. So to begin with, what is Gen AI? To make it very simple, the understanding, so Gen AI is basically the class of artificial intelligence. So it all started with AI, artificial intelligence and machine learning. So it's a class of AI wherein basically we are going to design the system in order to generate new content. So again, to make it very easy to understand, for example, I just type in a keyword, just a husky dog. So immediately the image on the right, if you can see, it's going to be, this is actually the image which is generated by AI. So we want to get the content. So whatever we type in or key in, we want the model or the system to generate a content related to that. So obviously this is not going to happen on its own. We are going to literally create a model and train the model in such a way. The model is going to learn from the basic data, but here the best part and how it is going to be different from the normal machine learning is it is going to generate the data, which never happened prior to Gen AI. It was only like the model was trained to do some task. Whatever you tell, for example, you give a label and you train a model to identify this image as a dog, yes, it will be, recognized as a dog. So first the object will be detected and the recognition will happen. But when it comes to Gen AI, the model itself is going to generate that particular content. So it is moved to the extent wherein the contents can be images, text, or even videos. Now, literally, we're moving to the level of videos. So yeah, the next one is to brief about the origins of Gen AI. As we all know, it all started with the machine learning, the initial phases. So thereafter, we were well versed with chatbots and wavenets, and slow and steadily we moved into something called as neural network, wherein neural network took a high progressive mode, and several neural network architectures and frameworks started coming into picture. And slow and steadily, today we are at the level of GPT. So I'll be briefing all the tools also at the end of my session over here, which tools we can, literally rely upon for 2024, the upcoming new year. Yeah, the next slide, Manu. So this is how the evolution of Gen AI actually happened. So to begin with, obviously it all lies with artificial intelligence, and we all know about machine learning, which is nothing but the branch of AI, which is mainly focusing on making the machines or models more intelligent than human. And immediately came up the concept of deep learning from neural network. And nowadays, deep learning has gone to the extent wherein we are going to focus on something called as optimized network. It's no more like just networks, but it's going to be optimized neural network. So thereafter, we came up with the concept called as the Gen AI. So basically, it is a type of artificial neural network wherein the data is going to be generated by the model. So completely new. Whatever data we feed in, using that data and deep learning with that data, the model is going to generate new data. Yes, next. So as I was mentioning, it's about the neural network and deep learning. So just to repeat with, it's a type of artificial intelligence technology. And as I was telling, it is not restricted only to text. Initially, when started with the Gen AI, was more focused to text. Then slow and steadily, they moved into images. Then they started, transcripting the audio to text. And nowadays, literally, the work is moving on towards video generation also. Next slide, please. Yeah, so I wanted to focus more on the fundamental and working principles of Gen AI. So the moment we tell generative AI, these would be the basic concepts or basic things which we should be aware of before kickstarting with generative AI. So obviously the first fundamental thing related to generative AI will be the data set acquisition. So it is slightly different over here compared to the machine learning and artificial intelligence, because here the major thing is going to be the voluminous amount of data. The more the quantity of data and more diverse the data set is, obviously the data generated by the artificial intelligence model seems to be more realistic. So that is a challenge, a major challenge over here, how diversified our data is going to be and the volume. And of course, in the next slides, I'll be briefing about it. It's not only just the volume of the data, but of course, the core features, the key features or the characteristics which we are able to capture in the data set also matters here. So that is more important with respect to Gen AI, the data set that we create. And next important thing is related to training data preparation, which means again, the model is going to be trained based on the data, whatever we have, we are going to train the model. So it is not as simple as a pre-processing task, which was existing in image processing and ML. So here it is slightly on the higher end, wherein we need to pre-process the data and we need to format the data by applying the concepts of normalization, resizing, and tokenization. My teammates will be briefing on it. So these will be the important pre-processing tasks, because as I mentioned just now, it's going to be a diversified set of data over here. So normalization will be the basic, and tokenization is part and parcel of the whole process in preparing the data. And next comes the model architecture design. I just wish to brief about generative model before going on over there. So obviously it is going to be a model selection. So basically we have several models linked with Gen AI. So which best model or architecture we are going to choose with? So first and foremost, before getting into those types, why we need a model here? So the models in Gen AI, they're going to learn the underlying patterns and structure, where we have a data set. Just now I was mentioning, we have a diversified data set. So the main aim of choosing a best model will be to learn the patterns in that particular data set. There will be some sort of pattern which is existing. Once our model becomes the best in identifying the trend or the pattern or that sort of a link between the features, it will be easy for it to create the expected content. So that pattern understanding, as well as understanding the structure of the underlying data set, is very important. So with respect to the problem in hand, what we are expecting the Gen AI to do, accordingly we can go for selecting the model. So to put in a nutshell, two important models are there. One is generative adversarial network called as GANs, and the other is variational autoencoder model. And there is one more terminology which is very important linked to it, will be the latent space representation. So these two models are the core with respect to any Gen AI model. And next step comes with respect to initialization. So when it comes to the models here, there is something called as parameter tuning. So we will be having certain parameters, and these model parameters need to be initialized, and then the whole training process will kickstart. So in the training process, the model will try to understand the data, whatever was fed into it. It will try to get, identify the trend in that data, and then it will be producing the results. So that is a initialization step over there. And as I was mentioning, training on diverse data set is very, very important in order to get the realistic and expected output. So that is the next important step over there. And the next important concept with respect to the fundamental principles will be the loss function. So what is this loss function in terms? Again, to put in a very simple way, first and foremost, the Gen AI model, what we have developed, the model will be aiming to, create a content which is not existing. It will collect the basic information and knowledge from the data set, but it wants to create a new content. That will be the aim of the model. Now, with respect to the end user, as a person, when we say we want to, for example, let me take the same husky dog's image. We can't expect a totally different image over there. Our expectation will be the real life husky dog image. But according to the Gen AI model, it is a new image which was created by the model on its own based on the underlying data set. So this is a sort of, a gap or something which has to be managed. According to the model, it is a new data, but according to the user, it shouldn't be totally unreal. So they will be expecting the real data to be produced. The model will be trying to fill this gap over here. So that is the loss functions which has to be taken care. Basically, the link between the real data and the generated data. That is the core. And next one is the mode collapse. So when it comes to the mode collapse, it is nothing but the challenge. Basically, it's a challenge in the generator modeling. So where the generator will be producing limited set of output. For example, if you consider a data set, it has 1 lakh features of characteristics per se. At times, it so happens the Gen AI model will be going only for the key features and it will start generating the data. But it may happen in such a way that there will be other features or other characteristics, those which are untouched by the model, which might be contributing to a different result. So that mode collapse also needs to be taken care. It's not just the key feature, but the extent to which the other characteristics or the features in the data set might contribute to the result also needs to be analyzed and taken into consideration. And the last important principle will be the ethical consideration. All of us know, be any tool, any particular technology, the basic ethics and the professional thing has to be maintained. So especially when it comes to the misuse of the Gen AI with respect to the defect technology, misinformation, and so many stuffs happens, everything has a negative side also. So those ethical considerations also needs to be considered and taken care. Next slide, please. Yeah, so I wish to just give an introduction to the core Gen models. My teammates will be briefing about this with use cases and specific case studies. So the first one, as I was mentioning, is nothing but the generative adversarial network. So when it comes to the GANs, the basic working of the GAN, if we see, it consists of two things. One is a generator, other is a discriminator. These are the two key components of any GAN. So there is a specific role which is being played by the generator and a specific role which is being played by the discriminator. So the moment we concentrate on the GAN model, we have to have an in-depth understanding of how the generator and the discriminator will work. So basically, if we see the generator, it will start off with a random data distribution. From the data set, it will be collecting a set of random data, and then it will be trying to replicate a particular type of distribution. It will be trying to figure out some distribution. There is some trend. There is some distribution which is happening in the data set with the instances and the values of the feature. So it will be trying to identify the sort of distribution over there. And based on that distribution, it will try to replicate. It will be trying to produce the new data over there. Now, what about the discriminator? Now, the discriminator, what it will do is its main role will be to differentiate between the real and the generated data. This is something what I was mentioning priorly also. So it will try to typically differentiate. This is a real data and that is a fake data. So what is the advantage here? Why we need the discriminator here is to give a sort of information to the generator whether that particular trend, that distribution selected by the generator, is it correct or wrong. That sort of trend which the generator had predicted from the data set or the features, is it perfect, or whether it has to be slightly modified, or some other features has to be taken as a key feature so that we get a more better output of the result. So that is very important. So this sort of balance is something which is best with respect to your GANs. So the generator aims in creating the data. Equally, the discriminator, the data in the sense here, very sorry, it will be concentrating on creating our output results, the images or a text or something. And the discriminator takes care in distinguishing between the real and the fake data over there. So mainly it helps to improve the generator's ability to produce a very realistic output. So this is how it keeps on improving. Even the first slide, when you saw that husky dog's image, to some extent we can tell it's like not a very real photographic image which was taken, but to major percentage, to a major extent, it was resembling and very perfect to that of the realistic image. So that would be the final aim of our GANs. Next slide. Yes. So the next important thing is the variational autoencoder. Another important thing which we should be aware of with respect to Gen AI. So again, this has two things. One is the encoder and the decoder. So mainly the variational autoencoder, it focuses on something called as, like encoding the input data into a latent space. So the latent space I'll be explaining in the next slide. Let me just brief about this now. So what is more important is it will be trying to pick the core features. For example, if I have 1 lakh features, okay, in my data set, my variational autoencoder, it will identify the key features, in best maximum features, which is going to help me in order to do the to generate the data, be it an image or a text or a video or audio to some other text signal, anything. So basically, this encoder, using this variational autoencoder, I'll be able to identify the core features, and these core features will be collectively placed in one location called as a latent space. So from there, we are going to, like pick the samples. It's almost like sampling. So we take the samples and then we are going to generate the output. So this, from the set of features or the characteristics, I pick the core, I place it in a location. From there, I pick the samples and then start producing the result. So this is how the basic encoding and decoding is going to happen. Next slide. So this is something what I was mentioning about the latent space representation. So basically, for our understanding, if you see, it is a for example, in the initial data set, we had a huge collection of features, okay, for say 1 lakh features. So basically, I want to minimize the dimension. I want to have very minimal feature set. At times, it so happens we might also have multi-dimensional data set. Every time, it need not be a single dimension. So for example, 3-dimensional data set, almost called as a data cube in data mining. So a maximum, I want to reduce the dimensions also over here, go for the precise dimension, as well go for the key features. So that collection will be my latent space. So from here, I will be picking the essential feature, and then based on those essential feature, the interpolation between the data points will be taking place. And finally, it will be helping us to explore some new results. That is something about the latent space. And this plays a very much key role when it comes to the auto encoding. Next slide. Okay, so I thought of briefing about the key concepts and techniques, again, the terminologies which we should be aware of with respect to Gen AI. So the first one is nothing but the transfer learning and pre-training. So as I was mentioning till now, the best advantage of Gen AI is we can have a very large data set, and we need to have it with the diversified data. And more important thing is a fine tuning of, the task, means generating the images or the videos and text. That fine tuning has to happen consistently, and based on the results, right, we keep on fine tuning it in order to get the more better result, a more generalized version of the result. As well, the errors has to be minimized and the convergence has to happen very quickly. So that will be another important thing related to Gen AI. Next important terminology is attention mechanism. This is another common term which you will see the moment you start working with Gen AI. Gen AI and attention mechanism is like part and parcel. So we should be aware of this terminology. So attention mechanism, to put in simple term, it is a mechanism which will be enabling the model, whatever we have developed, to just focus on very specific parts of the input data. I have so much of data. I'm just taking specific parts of it, only portions of it, in order to improve the generalization of the work. The model is going to generalize and give me a result. So how well we try to choose the specific parts of the input data so that the output is going to be more realistic. That is something which we'll be doing in attention mechanism. How well we select it, that will be the attention mechanism. Of course, hyperparameters and parameter tuning also will be part and parcel of this. Next important thing comes with respect to normalization. So I will just list out few. Common normalization will be batch normalization, layer normalization, instance normalization. So all these normalization techniques by default will be applying on the data set the moment you start working on Gen AI. So these techniques will be used in order to, as I told, to like pre-process the data and keep the data prepared for usage later. Next important thing is the concepts called as ML learning technique. Supervised, unsupervised, and reinforcement learning will become part and parcel of Gen AI. It's no more like it's a separate learning and all over here. So automatically supervised learning happens, but only thing is here we don't give as such, explicit labels we don't give. We give the data, we train the model on the data, we see to that the model understands the data very well and it starts creating the content. So that, and why it is called as self-supervised over here is based on its previous result, because we are going to train the model multiple times. So based on the previous results itself, the model learns on its own. So that is the sort of supervised learning which is happening. And of course, reinforcement learning happens by default, wherein we are going to, give some valuable inputs to the output generated by the model. And based on the positives like credits or something, what we give, the generative model updates its learning and it's going to give the better results. Next slide, please. Yeah, so applications, I think whatever I've listed out here is very, very few. Nowadays, name any domain, Gen AI is into it. So, but the core domains where already people are using Gen AI, it is full-fledged is, of course, healthcare domain. Next one is, like motion picture industry, it's already into. We all know to what extent Gen AI is working over there. And security services, they're more dependent on Gen AI, the results produced over there. And the search engine, default, all of us know something called as ChatGPT. Everyone has started using it. So it has become part and parcel. So, and the various location services. So as I was mentioning just now, it is not restricted to this, but these are the domains or the applications, the places where Gen AI is already well versed. People knowingly or unknowingly, we are using Gen AI in these fields. Next slide, please. Yes. So the various tools which we can, look ahead in 2024, which we can use as part of Gen AI. Next slide. So I just sort of just listing out the tools. Next slide, please. Yeah. So as we all know, the advanced version of ChatGPT is GPT-4. So the acronym of it is Generative Pre-trained Transformer 4. Basically, we are going to make use of GPT in order to generate, translate, and summarize a text very efficiently. And thereafter, we have DALL-E 2, which is an improved version of DALL-E. And mainly it is used for image generation from textual description. Just now I told, if I type in, if I key in husky dog, immediately I have to get a beautiful image of the husky over there. Next one is CLIP, contrastive language image pre-training. So this is mainly used for understanding and generating multimodal content. It's like mixture of contents over here, both image and text mixed over here. And mainly they use CLIP for image searching, image captioning, and visual question answering. Whatever I have seen till date, in several survey papers, the more application of CLIP will be towards image captioning. They are trying to give an image and they want the model, the Gen AI model, to give the captions for that particular image automatically. Next one is Mid-Journey. Text prompts are going to be used in order to create some visuals from the prompts. And GitHub, I think all of us will be again well versed with it. Gone are the days wherein we want to learn the coding, sit and do the coding. And students' favorite it is because the GitHub Copilot starts generating the code for you. You just tell what it has to do. It will give you the code right in hand, almost like a pre-cooked, not even pre-cooked. 90% cooked food is available for you. Run it and see to that you're going to get the output. And Synthesia is another one best AI platform, mainly to create videos. Similarly, we have Scribe. School children also started using this. No more essay writing, or comprehensive writing by the students. They just key in the title, whatever given by their faculty or professors. They're going to get the content in hand, mainly used by school kids. Next, we have natural language processing and understanding tools also. So like this, several tools are there, and these are the very famous and commonly used tools. As I told, without our knowledge itself, we are using these tools, and that is extent to which Gen AI is already into our lives. Okay, so with this, I wish to hand over the session to Professor Syed for the next topic. Over to you, sir. Thank you.
Hello all. Now I will be explaining about the different generative AI models. So the main three models in generative AI are GAN, VAN, and transformer-based model. That is generative adversarial networks, variational autoencoders, and transformer-based models, which use it in ChatGPT and GPT-3. So coming to generative adversarial networks are fascinating models in the realm of AI capable of generating new data that closely resembles the data they were trained on. They work through a unique adversarial computation between two neural networks, that is generator and discriminator. As we have studied about the generator and discriminator in brief, which was explained by Varalatchoumy M. So now we'll be concentrating on the benefits of GAN. So GAN will be benefited for generating realistic data, which can create images, videos, music, text, and 3D models. And it is used in data augmentation. They can be used to artificially increase the size and diversity of the data set, which is crucial for training other AI models. And it is also useful in creating applications for finding in various fields like art creation, video editing, drug discovery, and even personalized healthcare sector. And coming to the challenges of GAN will be training instability, mode collapse, and ethical considerations. Here, the generator will generate the image, whereas the discriminator will check whether the created image is same as the input or not. So next, coming to the variational autoencoder, here the block diagram in which we have input, encoder, latent space, decoder, and output. Now we'll study in brief about each of the blocks, that is input. The input of the VAA can be anything that you want to learn. A representation of, for example, if you want to train a VAE model with generate images of faces, you would input a bunch of images of faces into a VAE. Then coming to the encoder part, the encoder takes the input data and compresses it into a smaller representations. This is done by a neural network that takes the input data as input and outputs a latent variable in which it will go to latent space. So coming to latent space, in the latent space, it is a low dimensional space that is used to represent the input data. Actually, the dimensions of the latent space are typically much smaller than the dimensions of the input data. This is because the latent space only needs to capture the essential information in the input data, not the whole input data which we will be giving in the input. So next, coming to the decoder part, the decoder part takes the latent variable, which is the output of the latent space, and then generates a new piece of data. This is done by another neural network that takes the latent variable as input and outputs the data that is similar to the input data. So coming to the last block, that is output. So output of the VAE is the data that is generated by the decoder. It should be similar to the input data, but it may not be exactly the same. This is because the VAE is trying to learn the underlying structure of the data and not just memorizing the training data. So next, coming to the next part of the generative models, that is transformers. Here, the both encoder and decoder in a transformer architecture are crucial components, but they serve distinct roles in processing and generating information. Here's a breakdown of their key differences. Encoder will do functions. They analyze the input sequence and extracts its meaning. The components will be, as you see in this block diagram, masked multi-head self-attention attends to different parts of the input sequence to understand relationships between its elements. So the next FFN, that is feed-forward network, adds non-linearity and complexity to the encoded representation. So next, coming to the residual connections and layer normalization, improve training stability and performance. So next, the positional encoding, which is optional, we can add or remove from the transformer design, which helps the model learn the order of elements in the sequence. So coming to the next part, that is decoder, which is used to encode information from the encoder to generate an output sequence. Here the components will be masked multi-head self-attention, similar to encoder, but attends only to already processed tokens to avoid information leakage. So next, coming to multi-head attention over encoder outputs, attends to encode representation from the encoder to access relevant content from the generating the output. So next, coming to the position-wise feed-forward network, same as in the encoder, adds non-linearity. So next, coming to the residual connections and layer normalization maintained for stability and performance. Even in decoder part, we will be having positional encoding, which is optional to add or remove. It is same as functions in the encoder type. So next, coming to the output of the decoder, it will be a sequence generated based on the encoded information and the decoder's internal state. So the key differences of masking, focusing, and output will be masking. Encoder self-attention can allow access all the tokens, while the decoder mask future tokens to prevent information leakage. Coming to focus, encoder analyzes the input, while the decoder uses the encoded information to generate an output. Coming to the output part, encoder outputs a representation of the input, while the decoder outputs a sequence. Together, the encoder and decoder form a powerful partnership. The encoder captures the meaning of the input sequence. The decoder leverages this encoded meaning to generate a relevant and coherent output sequence. This collaboration enables transformers to excel in tasks like machine translation, text summarization, and dialogue generation. So these are the applications in which transformer is used nowadays to generate text and dialogues and machine translation. So these are the applications which transformers are used here. The most used transformer application will be ChatGPT-3 and GPT-4. Even now, even Bard uses transformer-based generative model. So next will be continued by Manu.
Next topic is generative AI for creative content generation. Next topic is generative AI for data augmentation and synthesis. Basically, what is data augmentation? Data augmentation and synthetic generation are techniques used to machine learning and data science to enhance the quality and quantity of the training data. If we come to the data augmentation is we are creating a data set by using the already existing data, and we are we are giving better accuracy data set. Data augmentation involves in applying transformers such as rotation, flipping, cropping, or color adjustments to exist data samples, creating modified versions of the original data. This helps to introduce variability and diversity of the data set, making the model more robust and less prone to the overfit. If we come to the synthesis data set, here actually generation involves generating entirely new data points using the statistical modeling or other algorithms. These synthetic samples are designed to mimic the patterns and characteristics of the real data, expanding the training dataset and addressing data scarcity issues. Synthetic data can be valuable when obtaining more labeled data in difficult, expensive, and over-consuming. Data augmentation generation. Here, what data augmentation is crucial technique used in the machine learning and AI systems that involves artificially expanding the training dataset by applying various transformers. Actually, here the dataset was created using the in data augmentation, the dataset is created using the already existing data, and if we come to the synthetic dataset, the dataset is entirely created by new by the machines. Data augmentation object generated new data instances, like it is mainly focuses on the computer vision by to classify the images. Benefits of data augmentation. Benefits of data augmentation is improved model generation. In improved model, exposing the model to a more extensive and diverse set of augmented data allows it to generalize better and becomes learn prone to overfitting and original training set. Enhanced model performance. In enhancing model performance, data augmentation introduces variations that simulate real-world scenarios, making the model more robust and capable of handling different input variations, such as change in lighting, condition, angles, and backgrounds. Reduces data collection efforts. In data collection, in this point, the gathering high quality labeled data set can be time consuming and expensive. If we use the data augmentation, allows practitioners to maximize the use of existing data, reduces the need of extensive data collection efforts, better utilization of resources. If we use GenAI to generate the data, the training models with more augmented data labels, parallel processing during training, leading to faster convergence and optimizing, which can significantly speed up the model development process. Transformability. In this point, models trained with the augmented data tends to be more transformable, perform better when applied to a new unseen data set and real-world scenarios. Synthetic data. Synthetic data is discover new patterns and structures. For example, we can create this data set by using the VAEs, that is variational autoencoders and generative adversarial networks, as explained previously by the professors. It is able to create the new data instances that resembles original data set and enhancing data diversity. Here improves model improves the model or generalize and performance. If we come to this point, AI can generate a large volumes of realism synthetic data, augment the real data set, variable data sets domains. If we have like where like it contains more data, so scenario domains, different domains, continuously generates fresh data. It can if we use synthetic data set, it is continuously use generate the new data set which will be reliable to the real world data set, faster, more capable and accurate machine learning models. By using the data sets, we can get an more accurate and optimized models to train the AI models. Advantages and potential applications of using the GenAI for the data augmentation. In this, the advantages of using this type data set, which is generated by GenAI, are one is improves training. A generative AI can generate large volumes of realistic synthetic data, augmented and original data set. Data imbalance mitigation. In many real world datasets, class imbalance are common, which can negatively impact model performance. Generative AI can address this issue by generating more samples of representation classes and balancing the dataset. And if we come to the data protection, here privacy protection is more important when generating the dataset. Generative model enables data augmentation without directly using sensitive data. Now, and next is innovation data. Generative AI can produce data samples outside the original distribution, allowing researchers to explore potential edge cases and uncover hidden patterns and investigate resource efficiency. Data collection and annotations are often time consuming and expensive. Applications of AI. It is used in medical imaging, natural language, and computer vision, and also autonomous vehicles. These are the few examples, and these are used in many applications. If we come to the medical images, generating realistic medical images can aid in training better diagnostic model, even with limited real patient data. If we come to the natural language processing, text generation is most example. Generating text variations can improve language-based models like chatbots and sentiment analysis. If we come to the computer vision, synthetic image generation can enhance object detection, recognition, and tracking algorithms. In autonomous vehicle, generative AI can create diverse driving scenarios, enabling safer and more robust self-driving systems. Prospects and opportunities. If we come to the prospect and opportunity, more in AI, generative AI is in data augmentation and synthetic dimensions are promising. With the with using the machine learning and deep learning advancement, generative AI models like GAN and the VAS will be more sophisticated, generating highly realistic synthetic data. This synthetic data will be indistinguishable from real data and facilitating broader and safer use in various applications, including training AI models for medical imaging, autonomous vehicles, and natural language processing. And generative AI will contribute significantly to data augmentation and the need of extensive and diverse datasets for training. This will be especially value when data collection is challenging or costly. And if we come to the augmented data sets will be improved model generalization and performance, reducing overfit concern. However, ethical consideration must be considered to enhance that the generated data does not reinforced bias in the original dataset. Generative AI has a immersive potential to resolutionize data augmentation and synthetic data generation, driving innovations across industry. And one of the model for example, this is the one of the model I took to explain video summarization model. Usually in video summarization model, what happens means initially the video was taken by the model. Initially the model can take entire video. It will split the moment. It won't take if we take for example any YouTube video. There will be an any video which is like they will introduce about their channel, and at last they will tell some subscription their channel. By removing all those channels, the model will remove that's part of the uh, model video, and it takes only 75% of video to encode. After retrieval of that video, it will after getting the moment retrieval, it will segment the video into many frames. That video is converted into many frames, and using that many frames, model the model is encoded, means encoded into many frames, and it will decode encode the whatever the features is there. It may use reinforcement learning to it will use reinforcement learning to extract the environment in the video. Usually, what happens if you have any video, the video is segmented into many frames, and many frames is, and after that, using reinforcement learning, the whatever the environment is there in each frame, the information is encoded. After encoding, decoder helps to text caption and summarize the videos. In what happens in decoding, it will take all the whatever the encoded text by the frames, and it will using the that is it is using that encoded text, it will decode to the human readable form. It will, after the evidence, it will give the description of the description of the video. And here many models which have prompt video summarization. If we give prompt to the model, it will give based on the prompt, the video will be description will be generated with particularly that video. Thank you. And next will be continued by Sadhana.
Thank you, Manu. So next, I'll be talking about generative AI in science research and discovery. So Gen AI's ability to generate new content, simulate scenarios, and assist in complex tasks has made a significant contribution to various fields in fields of science research and discovery. Although it is still in its earlier stages of development, it holds immense potential to revolutionize scientific research and discovery across various disciplines. So, here I have three such compelling examples that underscore the groundbreaking impact of Gen AI. We'll just wait for the screen share. Manu, could you screen share? So yeah, as I was saying, I have taken three such compelling examples that underscore the groundbreaking impact of Gen AI. Next slide. So the first one is basically drug discovery. Manu, next slide. So yeah, generative models have been employed to design novel drug compounds. So, by understanding their molecular structure and relationships, now AI algorithms can generate potential drug candidates. This basically will accelerate the drug discovery process and has a promising breakthrough in pharmaceutical research. So, here basically we will be talking about two major tasks. One is the molecule generation, and the other one is predicting bioactivity. Next slide. So, molecule generation is basically the process of using AI to design a new drug candidate. So either we start with a known drug and then make small changes to its structure, or altogether we can completely create an entirely new molecule from scratch. So there are some specific ways in Gen AI which can be used in drug discovery and development. So the first one is de novo drug design. So this is basically a process of designing new drug from scratch. Generative AI can be used to generate millions of potential molecules and then select the ones that are most likely to be effective. So, the next task is virtual screening. So, in this process, we make use of AI to screen through a large library of molecules for potential drug candidates, and we can basically identify molecules that have certain desired properties. For example, you want to find a molecule which has the ability to bind to a specific protein target. So that can be done through this process. And then we have the targeted molecule optimization or the lead optimization. So this process is basically of taking a promising drug candidate and improving its properties, such as the potency or selectivity. So these are the three tasks with respect to molecule generation. Next slide. So next is predicting bioactivity. So with generative AI, although it is a relatively new field, but it has potential to revolutionize the way we discover and develop new drugs. So now, using AI, we can predict how a molecule will interact with a biological target. For example, a particular protein or an enzyme. So as I previously said, we can screen millions of potential molecules much faster and more efficiently than ever before. So by doing this, we are going to discover and develop drugs that have fewer side effects and are cheaper to produce. Next slide. So the next example is in the field of physics and astrophysics. Generative AI offers a powerful toolkit for physicists and astrophysicists to explore the universe, understand its underlying principles, and make groundbreaking discoveries. So, the first one is create realistic galaxy images. So, using techniques like the variational autoencoders or the generative adversarial networks GANs, as previously discussed, and using the existing astronomical data, we can generate new realistic galaxy images with diverse colors, morphologies, and structures. So, next is to simulate authentic galaxy. So, we have something called the physics informed generative models. So, these models basically are going to incorporate the physics laws like gravity, hydrodynamics into the generative process, leading to a much more realistic and consistent galaxy simulation. So, next is exploring and understanding the dynamics of celestial bodies. So, we can identify hidden patterns and relationships and uncover new celestial populations or correlations. Like we can detect unusual objects, find the outliers or anomalies that might indicate a new phenomena or a challenging theoretical model. Next slide. So the next is an example of OpenAI's Dactyl. Dactyl is basically a robotic hand which is designed by OpenAI. It is trained using the reinforcement learning. Reinforcement learning is basically a type of machine learning that would allow to learn by the trial and error method. So, one of Dactyl's most impressive achievements is solving a Rubik's Cube one handed. So, this basically demonstrates that the system can handle complex tasks in the real world, which require dexterity and adaptation. Next slide. So, imagine a robotic hand performing surgery, or in the field of I'm sorry, could you please mute yourself? Yeah. Could you please mute yourself? Thank you. So, as I was saying, now when you imagine a robotic hand performing surgeries, now surgeries could be delicate surgeries could be performed through smaller incisions, which will basically lead to faster recovery rates and sometimes reduce the patient's discomfort. Now, Dactyle's fine motor control and adaptability also allows it, makes it easier to handle fragile things, and it helps in the manufacturing industry. Also, automating picking and sorting will be a great help in the warehousing. Next slide. So, I would like to give a gist about the, you know, boom or the current buzz in Gen AI, which is video summarization. So Gen AI models like the large language model and GANs can now be used to analyze video content such as audio, visuals, text, and generate concise summaries. So these basically have several benefits. Imagine you're watching a 1 hour or 2 hour video and you don't have enough time to go through the entire video. These auto-generated summaries can be of a great help. Next slide. So one such is the video llama. Llama basically is large language model for multimodal analysis, which is basically a cutting edge AI system that is revolutionizing how we are going to interact with and understand the videos. So basically how llama summarizes is with these two concepts. First is capturing the temporal changes in visual scenes. When you talk about temporal changes, for example, if you take the example of the CCTV camera or the traffic cameras, every particular minute or every particular second there is certain changes that is observed. So that is what we are speaking of temporal changes. And the second aspect is integrating audio visual signals. So towards the right, the picture basically is the architecture of the video llama. So if we look into it carefully, in the input processing, we are feeding in with a video, and we have towards the left the video encoder and towards the right the audio encoder. Video encoder basically is going to process the video frames. So here we would be extracting visual features like the shape of the object, motions, scene context, etc. And in the audio side, we would be extracting audio related features, for example the audio track capturing speech, music, or the background noise. So then we have the multimodal fusion, which is basically the audio visual transformer. This is a powerful transformer model which basically combines the extracted features from both the branches, the vision branch and the audio branch. So you can basically consider or think this as a blender or a mixer. So it's going to mix both the aspects and the extracted features from the visual as well as the audio streams and creates a richer understanding of the video. Suppose in case we also have a text fusion. So in case if any text is available, it is going to be integrated with the AVT's output here. And further it will enrich the model's understanding of the video. So last one is the output generation where we have the decoder. So this basically depends on the desired task. What exactly do you want your model to do? Suppose you wanted to generate captions or you want a Q&A session with the model. So the decoder is basically like a translator, it basically turns the model's understanding into human understandable language or other relevant forms. So if I have to sum the overall architecture, we can consider it as a multi-layered cake. So in the bottom layer, we have the video and the audio encoders, which are basically going to extract the raw features. In the middle layer, we have the AVT and the text fusion, which acts like the mixing bowl that are going to blend the ingredients into a cohesive understanding. And in the top layer, which we can say like a icing on the cake, we have a transformer that is going to give us the desired output. Next slide. So here we have few examples of the video llama. The picture to my left is basically, if you see the prompt, it says, how was the audience response? So here the model basically is extracting the audio features and it is able to predict the audience was really enthusiastic and clapped loudly for the performer. It is also able to detect what kind of instrument is being played in the background or by the person. If you see the image towards my right, so it is basically when prompted, do you know who the man on the right is? The model is correctly able to predict the real as well as the real name and also the name of the web series. Next slide. So this is again an example of Video Llama's performance. Image to the left, it when prompted what is unusual about this image, it is able to detect that a yellow shirt man is standing on top of the parked car while holding an iron board and pressing clothes. This is something that we wouldn't be seeing in general scenario. And the picture to the right, it gives a brief, I should say a very brief and detailed description about the woman in the video. If you could pay attention to the words, the highlighted blue words, red haired woman, striped shirt. So these are few examples of video llama. So next, Dinesh will be taking ahead.
Hi everyone. Manu, can you please share the PPT? So coming to the generative AI for creative content generation, like basically why it is used in content creation. Let us know about it. Next. So initially, it is used for increasing creative output. So what is increasing creative output? It is basically a generative AI that can significantly increase creative output by automating tasks like brainstorming, drafting, and editing. Like this frees up the human creator to focus on the more strategic and conceptual work. Let us take an example of it. Let's take an example of a writer who could use a generative AI tool to generate multiple stories outline or different creative writing prompts, then select the most promising one to develop further in. So this is about increasing creative output. Coming to it reduces human effort. So how it is reducing the human effort is generative AI can handle many time consuming and repetitive tasks involved in creative content generation, such as like generating varieties of existing content and also providing personalizing the content for different audiences and or adapting the content to different formats. So basically this can significantly reduce the workload for human creators, allowing them to focus on higher level tasks. Coming to expands creative horizons. What does it mean is generative AI can help creators explore new ideas and possibilities that they might not have considered on their own. So by exposing creators to a wider range of options and styles, generative AI can help them break out of their creative thoughts and come up with more original and innovative work. And it provides new perspectives. Generative AI can also analyze large amount of data and identify the pattern and relations that humans might miss. This can provide creators with new insights and perspectives that they can use to inform their creative work. Now, let us take an example of it. A musician could use a generative AI tool to analyze a collection of popular songs and also identify common music patterns or the chord progressions. So this information could then be used to create new and original music. Next slide. Generative AI in generating images. What are its capabilities? So capabilities are like it creates a realistic and high quality images from the scratch and also generate images based on the textual description. So whatever you want to develop an image, you can just provide a description of that image and it will generate the image and also restore damaged or incomplete images. Coming to its application, it is mainly used in art and design, like create unique artwork or illustrations or design elements. Also, it can be used in product development, science and research, and personalization. Personalization in the sense, create custom images for like social media, advertising, and other applications. So one of the popular techniques in generating images are style GAN. As it was explained by professor, it is a type of GAN specifically designed to generate high resolution images with realistic textures and designs. Coming to an example of it, one of the most famous example is DALL-E 2. What does it? I think most of them will be knowing about it. What does it do is it creates a realistic and detailed image from the text description which you provide to it. Coming to the benefits, it reduces the human effort and also time required to create the images. Like if a human takes to create the image, it can take much time to create it. So this AI can help the user to create the images very quickly. Coming to its challenges, it is very difficult in controlling the output of generative models and ensuring the results are consistent with the user's intent. And also it can be potential for misuse and spread of misinformation. Misuse in the sense nowadays the deep fake images and like those types of images are going viral. Same like that. Coming to the future of generative images, as AI technology continues to develop, we can expect to see even more realistic and creative image generation capabilities. And the generative AI will likely become increasingly integrated into our everyday life, impacting various industries and creative processes. Next. Coming to generating videos, what are its capabilities? It can create a realistic and high quality videos and also generate videos based on the text description or scripts. So basically, you provide a description through the text, and it will convert the text into a video format, which will be a high quality video, and also generate video game assets and backgrounds. Coming to its application, it is used in animation and films. Animation in films like create animation characters, special effects, and also the virtual sets. It can also be used in education and training, and social media and entertainment. Some of the One of the most popular technique is video GAN. A video GAN is a specific type of GAN designed for video generation, capable of creating high resolution videos with complex motions. And example of it is Synthesia, which was explained by a professor. It is basically a platform used to create realistic videos featuring AI-powered avatars that can speak and move according to your scripts. And benefits of it is it reduces the production cost and time required to create a videos. So basically, in a less period of time, it can create a video based on your inputs. And coming to its challenges, it ensures the quality and consistency of generating videos specifically for complex scenes. And the future of generating videos through Gen AI is as AI technology advances, we can expect to see even more sophisticated and realistic video generation capabilities. Next. Generative AI in generating music. What are its capabilities? Capabilities are like composing original music in various styles and genres, generating music accompaniments and soundtracks, and also creating personalized music recommendations, and automating music composition tasks for faster production. Coming to its application, it can be used in music production, like generating background tracks, instrumentals, and even completely the songs. And it can also be used in film and video games, in education, and also in entertainment. Entertainment is like create personalized music playlists and generate music for interactive experiences. One of the popular techniques of generating music is RNN, which is recurrent neural networks. So basically, it learns the patterns of musical sequences and generate new music that follows those patterns. And examples of it is jukebox, that generates complete songs in various styles from pop and rock to classic and jazz. And also we have MuseNet and Amper Music. Coming to its benefits, it can increase creative possibilities, which is nothing but allows musicians to experiment with new sounds and styles, and also reduce the time and cost. So it will speed up the music production and reduces the need for human musicians. What are its challenges? So challenges might be ensuring music quality and originality. Basically, AI generated music can sometimes lack the emotions depth and human touch for traditional composed music. So we can ensure the quality of the music of it. And ethical concerns. Ethical concerns are like questions surrounding copyright and ownership of AI generated music, and also in limited control over creative direction. Coming to the future of generating music, we have like as AI technology advances, we can expect to see even more sophisticated and expressive music generation capabilities, which will be soothing to the humans. And also the human AI collaboration will be likely become increasingly common, with AI assisting and musicians in various aspects of music creation. And also AI generated music could have significant impacts on the music industries, affecting everything from music production to copyright laws. Next, it will be continued by Dhanush.
Hello, everyone. So I'll be continuing with the Lavila model. Give me a second. Yes. Okay. First up, we have Lavila, which is a model that is a new approach to learn video language representations by leveraging large language models, which is achieved by repurposing pre-trained LLMs to be conditioned on visual inputs and then fine-tune them with human narrations to become automatic video narrators. The advantages of Lavila are that it provides a dense coverage of long videos, higher diversity of text, and free annotations compared to pricey human annotations. A dual encoder model is used, which contains of a video and a text encoder. So the video encoder uses a clip and zero init transformers to initialize, whereas the text encoder uses a GPT-2 based transformer and is also using a clip model, a clip transformer to initialize. The training process of Lavila involves the use of two large language models, which are a rephraser and a narrator. A rephraser is an LLM which rephrases the captions or subtitles given for the video. And the narrator is a visually conditioned LLM which is used to generate text or narrations based on the context in the video. A dense narration by the rephraser is performed by recaptioning the human annotated clips in the video and then using narrator to generate the captions for the remaining clips. After which, the clips with low similarity scores are filtered between video clips and narrations are generated using a pre-trained dual encoder model. Here are a few examples that demonstrate the working and the performance of the model. So I've given a video over here as a sample. In that, it says a woman who is pointing at a door where it doesn't exist. But yeah, that is the example of Lavila. Next, let's talk about the ethical considerations and societal implications of generative AI. Generative AI is a rapidly evolving field with the potential to revolutionize various aspects of our life, from healthcare to art. Generative AI isn't just mimicking, it's co-creating. Imagine collaborating with AI partners like Bard to craft compelling narratives, DAL-E to forge photorealistic imagery, or MuseNet to compose original soundtracks. Navigating through the ethical crossroads. Although with immense power comes immense responsibility. We must vigilantly address bias in training data to prevent perpetuating harmful stereotypes, job displacement risks, and potential for deepfakes to weaponize misinformation. Demand a proactive approach. Only through prioritizing ethical frameworks and open dialogue can we ensure generative AI empowers and not exploits humanity. Why does generative AI matter in the first place? Why should I know about it? Generative AI has the potential to transform countless industries by automating tasks, personalizing experiences, and fostering innovation. Imagine AI-powered robots streamlining assembly lines in manufacturing on custom learning platforms, tailoring education to individual needs. In healthcare, generative AI could accelerate drug discovery and personalize treatment plans, leading to better patient outcomes. Generative AI can also analyze vast amounts of data to identify patterns and solve complex problems that would be intractable for humans. This could involve tasks like optimizing traffic flow in real time, predicting natural disasters with greater accuracy, or even tackling climate change by modeling various mitigation strategies. The ability to process information at such a scale opens doors to solving some of humanity's most pressing challenges. Generative AI can automate tasks like marketing copy, designing product mockups, or even composing music, freeing up human creativity for higher level thinking. This can streamline workflows and boost productivity tools. However, it's important to remember that AI generated content should complement and not replace human creativity. Some of the ethical and societal concerns include bias. Generative AI models trained on biased data can perpetuate harmful stereotypes and generate discriminative outputs. Mitigate, mitigate- please mute yourself. Mitigating bias requires careful data selection and algorithmic auditioning. Job displacement. Automation through AI could lead to job losses in certain sectors. It's crucial to invest in reskilling and retraining programs to ensure a smooth transition for displaced workers. Misuse for fake content creation. Generative AI can be used to create deepfakes and other forms of misinformation, posing threats to online security and democratic processes. The ownership of generative AI content and privacy of data used to train AI models are complex, legal, and ethical issues that require careful consideration. Clear guidelines and regulations are needed to ensure fairness, transparency, and accountability in the development of AI. Potential risks and biases of generative AI. So in potential risks, we have first is deepfakes, obviously. Malicious actors could manipulate videos and audio to spread disinformation, damage reputations, or sow discords, such as fabricating political speeches or fake celebrity endorsements, influencing elections or swaying public opinions towards that actor. Deepfakes could be used to make it appear as if trusted figures are saying or doing things they never did, eroding public confidence in institutions like the media or government or the concerned political person. Perpetuating biases. AI trained on the biased data can amplify existing societal prejudices, leading to discriminatory outputs, undermining trust and spreading disinformation. Fueling the spread of falsehoods, AI generated fake news articles or social media posts could quickly go viral, making it harder to discern truth from fiction and hindering informed decision making. These are just a few examples of how generative AI could be misused. It's important to be aware of these potential risks and develop safeguards to mitigate them. Responsible development and deployment of generative AI is crucial to ensure its benefits of society to society as a whole. We've reached the end point of our workshop. So now let's discuss about the future of generative AI. Generative AI is just like a canvas for imagination. Generative AI is still in its nascent stages and hums with immense potential, ready to explore onto the world stage. It's not just about mimicking, it's about co-creating, pushing the boundaries of art, science, and human connection. Imagine educational simulations so immersive that it transport you to ancient Rome. Generative AI will eventually blur the lines between reality and creation, fostering a deeper engagement in and understanding. Generative AI will birth entirely new genres of music, dance, and visual art, offering a kaleidoscope of experiences never before conceived. But with such power comes great responsibility. We must carefully navigate the ethical minefield, addressing the issues of bias, data privacy, and the potential for misuse. This future demands open dialogue, collaboration, and commitment to using this technology for good. So, as the curtain rises on this new era, let's step forward with open minds and open hearts. Let's embrace the possibilities, the challenges, and the boundless potential that awaits. Remember, the future of generative AI is not pre written, it's a canvas on which we, as humanity, can paint our collective vision, and together we can make it a masterpiece. With this, we end our workshop. Thank you, guys.
Nice presentation. Thank you, Cambridge Institute of Technology, to give a wonderful presentation. Now the floor is open to the participants to ask questions. You can straight away unmute yourself and ask question, please. If you have no questions, or if you want to think and write to us through email, we'll also share it to the team to work out solutions towards it. So with this, I think there's no questions from the participant side. We'll say closure to this workshop. Thank you all for participating in this workshop. And for the participants, please fill your attendance sheet and claim your participation certificate. Thank you all. Thank you all who presented on behalf of Cambridge Institute of Technology, Professor Varalatchoumy, Professor Syed, and teammates. Bye.